everybody. That's right. All right. It's working just fine. Now we're trying to figure out about coil shorting. So we can hook up a shorting circuit on the other side. And hopefully it could find, an even speed instead of just continuously getting faster. Especially when the battery is like all the way charged. That's what it likes to do. It's just keep on getting faster. But if it has a little break in there, like a lens effect on a shorting coil, and here I'm going to show you just basically what it's made out of, what the coils are made out of. There's a 2,222 turns of 30 gauge on this pickup coil, and it's virtually the same size and weight as this drive coil, which is 20 gauge and 28 gauge. So in either the 28 gauge and and we can put the 28 gauge and the 20 gauge in series and make it a single coil that is 400 turns in length, 5 ounces, and current limited to 28 gauge. So, or we could just do 200 turns of 28, which would be a sixth of an ounce, a very little amount. And if we roll a new coil, I mean, I have some 26 in my garage, that's our bobbin. That's what we roll it on if we were to roll another one. See, it has to fit on the system, or you just scrap the whole system and you start over again. I don't think it's that bad. Just to incorporate an idea, I don't think you even have to, roll another one. If you want low current, high impedance, you'd probably do the pickup coil. Honestly, you'd use the pickup coil. This would probably be too much, though. Too much lens effect. We're just trying to get it to slow down a little bit. I just need to know how to build the circuit so I can try it. And I've got like maybe the beginning of the circuit, but that's not going to do the trick, or it hasn't so far. Or we do, you know, we figure out which coil we're gonna short, and we set that circuit up, and then we slap it at the 180 of the drive coil. Heck yeah, thank you. Welcome. We're trying to get it to slow down a little bit though. It will spin both ways. Wow, that's a lot of force. I really had to try to like stop it. You normally like, let me get this other rotor up from down here. Y'all know what that's it. Just your typical rotor with all the magnets on it. Yeah, I can normally stop this one within like really fast. It doesn't matter how fast it's going. And this one's heavy, like flywheel application. It's 100% infill in the toroid and 8 neodymium cubes. The only problem with this one is that the cubes are really close together. So you can never get its full potential because the motor doesn't work exactly the way it should. It does work though rather well, I might add. You know, I can get it up to 1700 RPMs maybe, and that's really wicked for something that like this heavy. That's kind of scary. Because, you know, it's ceramic bearings, it's plastic, and you're thinking to yourself, man, what if those bearings like freeze up or something? What happens then? This is going to make a really loud noise, if not throw things everywhere. But this is exactly the opposite, basically, of that. And you got all your coils on the rotor. And in order to make that work seamlessly, you need to put your power source and your circuitry on the rotor as well. Because I mean, when the coil's out here and it can stay still, then you can tether it down to like a power supply or anything like that. But when it's built like that, you have limitations, and your limit is how much space you have on your rotor. And you know, honestly, let me show you. I don't know if you can see it without me taking it off the pole. Kinda. The base. See how this is a cone-ish shape? I would cut it off like right here. Make it flat. So it look more like a saucer on the bottom. And then on the top, make it look like a saucer as well instead of the cone. And the cone's really cool because when you put the two cones together, like, well, bam, you get the U-tron. And it's really, I don't know, I think it's a really cool shape because you get the square when you look at it from the side, you get a square, because the height of a neutron from a neutron cone is half the length of its base in the center. So when you look at it, you got a square, and when you look at it from down the barrel, it's a circle. So and you got to make it that way. You got to make it the height from here is half the length of the base. That's the rule. Do it another way and you don't get a square. Okay? Hello. How's everybody doing? Sorry, I've been real involved. Hello. I'm trying to figure out how to make a shorting circuit, coil shorting, so that we can make this run smoother. I think that could get into a nice rhythm. I gotta print a new bass though, because the bass is on a wobble, and I'm not so sure that wobble is, sacred. But I think it's cool. Get a nice straight one of these. Then I feel like I could let it spin, counter spin, until it finds its equilibrium, until it, finds out where it's going to be. Where it's going to be, when it's going to be, how it's going to be there. And no, basically, not this iteration, because it's, for what I want it to do, it's really unbalanced. But I want it to spin so fast that you can see through it. And I know that this one isn't going to do that. And, but that seems like a plan, man. I've been like, I had a plan of getting a rotor up to 5,000. But, when I stumbled out at like 1,700, I said, yeah, man, I don't think that's going to work. I don't think we're going to do that. I started to let go of that, but I want to see how fast this one is going, for one. Yeah, it's a DC brushless motor that can counter rotate. And what you got to let it do, I know it seems like the best thing to do is to make this stop and have the inward spin, or to make the same setup and have the magnets in the middle and the coils on the outer edge, which I may make an iteration like that. And have the batteries and the circuitry all on this platform here, and have the coils where the magnets are. Seems like a good idea to do that. But as for this one and anything like this one, it kind of be the same deal. It's not like you could then all of a sudden hook up, unless you got like a commutator ring thing. And you got to realize the standard commutator won't work on this build because the shaft is fixed. Okay, the shaft isn't going anywhere, it's not spinning. So, I mean, you can't attach the commutator ring to the shaft because the shaft isn't moving. Let me think. I'm trying to move forward in the design because we got a drive and it works well. And it's just one of these coils. Just one. And it works really good with 12 volts going through it. But we want the other side to be a shorting circuit. All right, so let me break it down in the weight and the balance of this thing, okay? And one time I had it set up with 4 batteries inside, one on each. All right, let's lift this up. Okay, you can kind of see it, but underneath the tape there is a box with 4 pegs on it. And you got, in this iteration, you've got 2 batteries that are at, let me show you. I want to put it back down now. I just wanted to show you that box in there. So at these ends, there's a battery in the box at each end. So there's 2 batteries in there. And then to balance that off, I put the 2 next heaviest components above the batteries. Okay, so there's no weight on these ends really, except for the coils, which are balanced. The same coils are on both sides. And then the breadboards go kind of across the middle and are shared by both sides. So it's like a 180 split with the weight. And I've had it go 90 degrees and 180 degrees and work pretty good. But you know, once you start putting single components in there, even this, dude, if you even put this in there, you might need to put another one in there to balance the weight. I'm not joking. Okay? Yeah, you want to charge a drill battery in here. You want to do that, you're going to need 2 of these. At least 2 of these, if not 4, to balance the weight. Okay, you can't just put things in there. I know people's minds like to do that, but this especially this build right here, you can just look at it and you can tell there's not much room for anything else. If you understand weight distribution and balance, if you understand that, you understand that this is pretty much done. You know what I'm saying? Now what we can do is we can change the circuit from a drive circuit to a shorting circuit. Leave this circuit the way it is, but change the other side. And we don't change any of the weight. We don't change any of the weight. And as you can see, we generate a lot of electricity with this thing just from having it be on. And yes, it does have to be on in order to generate that much. But every chirp, there's a 90 degrees Every 90 degrees, there's a pickup coil that's in series. And then it's all hooked up to this camp anchor over here. The one with the red lights on. Hello. Hey, Yanni, what's up? Sorry, I've been really involved over there. So hopefully I can get somebody to share with me a complete breakdown of a shorting circuit, either on my Discord or via email or whatever. I believe most of that stuff is on my channel page. If you go to the ... at the end, the more at the end of my intro, there should be a more section that'll give you my email and my Discord information. Because if I can put the lens effect on this coil and then have this coil be the drive coil, don't you see how that will create harmony? Especially if it's just a little lens instead of a big lens. All right. Now, all right. Now I do see, there's a power supply here. There's a battery here. There's a cat bank, super cat bank behind that battery. There's another battery over there. But the only batteries that I got to worry about right now are the ones that are in here. Now they're 12-volt batteries. These are the exact model that are in there right now. These right here. I might need to charge them up, actually. I think they're nickel. Nickel halide or something like that. And I need to charge them up. And I'm not sure whether or not I can, charge these batteries with like a charging system, DIY charging system. The only problem, I mean, like if I can do a microcontroller that doesn't need to be connected to this in any way. Like if I can put it on here, as long as I can disconnect it, that connection from the computer, I think I could do that, honestly. As long as I could get one that could fit like right there, and then one that could fit like right there, because I would need two of them. Yeah, you would need two of them. Okay. All right. And then they would need to be self-running after you program them. 100%. Then yes, absolutely. They could be incorporated in, no problem. Because eventually you're just going to stop it. And but yeah, you can't leave it hooked up to your laptop or your computer and run it and have it work. That's not how it works. But I don't know how the stuff you're talking about works. I think there's options. Yeah, I think I can. Well, actually, I don't know. Because anywhere in between, I don't know, man. They got to be like at least this big. You know, 9 volts way too small. There's not enough capacitance in a 9 volt to run this thing, as far as I can fathom. The reason I use these ones is because of the 2000 milliamp hours. And the weight is good. I mean, if you balance it out with a second battery, the weight is like perfect. But you're right. If we, Yanni, what do you suggest? Think a 9 volt? All right, and 18650, huh? Yeah, well, I don't know. I guess I could try different batteries, but like, you know, what's going to limit is they got to have ends like this. They can be shorter, but they need to have ends like that, because then they will connect to the system. Now, I do have 9 volt connectors. Like that, and we could put a 9 volt in there, but I don't think a 9 volt. We'll see how long it goes for, because the ease of use is, I think the bigger battery's got more plus on that one, because I can just see having to change the battery quite often. But I might be totally wrong with that. I might have a more efficient energy system here than I think. So 9 volt batteries, that would be a way to slow it down for sure. Maybe. You know, I don't know exactly, since the resistance is a little weird on this. The sweet spot may be lower than 12 volts, but I don't know. Can't really tell right off the bat. I've only used 12 volts, so. But yeah, I guess 9 volts would be the next step. Step down, because it's a little out of control. Does anybody agree with me that it's a little fast? And the way I have to stop it is a little rudimentary. lots of energy in the cat bank connected to the pickup coils. So that's really good. That's what the whole problem was. I'm glad I was doing this. Oh man, this is gonna be rough. Got it. Oh, I can't believe I got it so quick. All right, that's the trigger. Hmm. Something else isn't right. Well, I'll have to deal with this. Make sure that that's attached. Because if it's on, it should draw the energy from the cat bank when I turn it on, and it's not doing that. So that means something is not connected. somewhere around here. I'll work on it more later. This part, I mean, I don't think it's working. But it looks cool. So seeing if the base maybe triggered that the energy would go away. Look, no, it's still there. Okay. I think this is going to require this. Is, right now, I'm trying to get in any suggestions that are within reason. Hmm. Yep, that's right. I just, huh. Man, I don't understand. It's all good. There is a misconnection on this, and I need to find out where it is, but I don't know where to start looking right now. Because normally it fires with 2 drives instead of 1. Could see how hard that would be to stop. That would be crazy hard. Why is that the most important question, Shadow? It is used to soothe my inner self. That's what it's used for. And it uses the same principle as any other DC motor to run. So there's its application. I would like it to be a little bit easier to use though. So if anybody could fill me in on how to do a shorting circuit, I would be really appreciated. Yo, what's up, man? Thank you. Hall effect, man. You need to help me out with this shorting circuit, man. You know how to do those? Yeah, shorting the coil, meaning you basically connect both ends for a split second every once in a while so that it may be timed with the magnets and it creates a lens effect. So I could use that on the opposite side to slow it down. But I don't know how to set it up. It's as balanced as it's going to be, yes. I've ensured for the most part that it is quite balanced. You'll know if it's unbalanced because everything will shake the whole time it's running. Hello, hello. It's a DC brushless motor with the rotor. The rotor's got the electromags on it instead of the stator. See, I didn't make it spin the other way. It does that on its own. I'll just give it a second. So it needs to be more balanced than it is, but it's more balanced than any of the previous builds. Let me put it that way. So what we have is we have 10 ounces of copper on 90 degrees. So that's 10 ounces at every 90 degrees. And then we have one of these batteries at 180, or two at 180. So we got two batteries like this all the way down in the chassis. Then we got these two cap banks on top of the batteries, and then we got these two breadboard across the center. So I would say the weight wise, it's very evenly distributed. As for being completely balanced, I don't know. Maybe there might be something like rooted wrong with the print. That's possible. Oh yeah, that's right. That's cool. Heck yeah. I gotta get a hold of Brandon then. All right. Thanks, Kale. Yeah, I'll check you out. Are you still last time I talked to you, you said you were taking a break. Well, yeah, I could basically just lower the input volts to start. Definitely. Now I have those. Where did I put it? Right here. Here it is. I got ones that I can use like this, or I got the big ones with the switch, the on-off switch on them. I might use the big ones because I got room. I gotta find those. Yeah, man, that's gonna be good. I mean, we gotta I gotta see how long a 9 volt will run this thing for. Might as well try it. I'll definitely consider all suggestions for future prints. I don't know if the smaller magnet, because I mean the trigger coils are 200 turns of 28 gauge, and these barely turn them on. And you got to spin it pretty hard to get them to turn on. Yeah, and if there's going to be like any Hall effects, we need to like. I've never made a successful Hall effect circuit, and every time I do get the thing to move, it always burns out on me like within a little while. So I need a good circuit for the Hall effect sensor, and then I need to build in to the rotor a place for it to be. Something shorted out the other day though, because I had unplugged. I was trying to do a shorting circuit, and I unplugged the ground, and I turned it on, and it was spinning, and then I saw a spark, and I knew something grounded, and I don't know what it is. I've changed 3 transistors already, and it's not the transistor. So something else, connection, because these jumper wires aren't the most reliable things all the time. So I'm going to have to strip it all down, put it all back together. So I am taking suggestions. I'll let you guys test that one out. Right now I'm trying to achieve a braking mechanism for my motor. There's 2 ways to start it. You spin the inside, which way the outside gets a longer time to speed up. But as long as you let it be natural, it will get faster each rotation, and it will catch up with itself, and it will time up. Except, it's gonna, it cycles, so it's gonna time up again and again and again. Now, if you just hold it steady, it's gonna go fast. It's debatable at this point as to which way is faster, though. It is. It's truly debatable. So I am going to show you way number 2. You spin the outside, and it gets going faster earlier, and the inside takes a little bit while to spin up. But it's always going to spin up pretty much the same rate of speed. But now the outside's going way faster. But if we just hold it here and we let it spin up, it's a little unbalanced once it gets really, really fast because it's so heavy. It's all the weight. And there's an uneven distribution of weight somewhere, and I don't understand where it is. Probably the 2, when there's 4 sides, having the 2 weight side. It's something about doing 180 when there's 4 sides to it. Wow, it's amazing. You know, and it's cool. I appreciate the lingo. Actually, I don't. You know, to me, it's something that could get going so fast that you can see through it. And it's not because it's not there, it's because it's going so fast. And I've seen things going that fast before, we all have. But one of these, maybe, somewhere. The one blade that cuts the zucchini going 30,000 revolutions is like a second or whatever. That's fast. You can't see it moving because it's fast. Awesome. And it is a little off balance, I would have to say, and I think it's because of exactly the reason that I just mentioned. Now, if I like put these two batteries in here at the other 180, I bet it would balance off nicely, like oh, really nice. So let's see if I can even do that. All right. Yeah, it's not gonna come off without me taking everything, undoing all the coils and doing all that. And I don't mind doing that. I'm not gonna do it right now. I was gonna say if I could just lift the plate up, but then I remembered I glued the batteries in so they wouldn't move around. And then I put a little bit, I glued this plate on there, which was not probably the smartest thing to do. So I'm gonna need to undo all the coils before I take that off. I'm definitely gonna break one or two. And I haven't had much luck with breaking coils. The start end always is the one that breaks. You know what? I might end up just printing another rotor and then undoing this one and then just trashing it, reclaiming everything. I could just imagine the torque with two of these on, man. That'd be nuts. My finger couldn't handle it. Well, there's no heat. There's literally no heat in the circuit. I mean, the coils don't even get hot. I mean, it's probably because I don't let it run very long, but for the little time I do let it run, it doesn't get hot. I'm, it's not. I thought I might have felt some heat on this drive coil, but there's not. And let me make sure they're both off. And then I'll touch the transistor. Yeah, not hot at all. It's a good circuit. It works really, really well. And it's the simplest circuit you can do with a transistor that involves using a light bulb across the collector and emitter. because it's virtually a 1, 2, 3 circuit. One on the base goes to the trigger, the positive end of the trigger. Then there's 2 connections to the collector. One goes to the negative end of the coil, and the other one goes to one end of the light bulb. And then the emitter has 3 connections. You got one that goes to the negative end of the trigger, one that goes to the ground, and one that goes to the light. And then the last connection is, of course, your positive end of the power supply to the positive end of the coil. And then your circuit's complete. And that one works. It works really good. Not a lick of resistance, and it works freaking awesome. No heat anywhere. No, I'm not really trying to change the design too much. I know that this design can be balanced, and I'll work on doing that. I'll watch a video. It's not a bad idea to watch a video on balancing objects. I'd say if it's off at all, it's a very little bit. And I do think that adding those 2 battery packs to the other 180 would balance it out 100%, because it's a square. Makes sense to me that you would have 4 sides of a square. Yeah, I think it is pretty. I mean, there is a small, I can see it in the light over here. This is how I measure the balance. Okay, if this light is shaking, then it's off balance. That means the weight is throwing it off balance when it's spinning. As you can see, it only happens when I start it up, and that's the momentum of my hand. It has nothing to do with this. Because it could be light as a feather, and it would do the same thing. Because it's my hand that's causing the rocking. All right, so this is the wiring that's in there right now that I'm using as a coil for the drive coil. It's this coil right here. 200 turns of 20 and 28, man. And this coil, it blows everything else out of the water, dude. There's no other reason. There's no reason to have anything bigger than this. Especially if you're going to put it on a shelf somewhere. You don't want anything bigger than that. And yeah, I think as a 16-year-old kid into electronics would love to play with something like this. I think that. Just got to make it safer. Now, the mechanism in here that charges the cap bank to make it usable DC is this right here. This mechanism right here. No core. You see how there's no core in there? You don't need a freaking core. You don't need a core. A core might actually give you a little bit more juice on the gen, but you don't need a core. No way. So, and the reason I say you don't need a core is because you don't need one. Yeah, you can have one, but then you're going to have to rebuild your whole thing yet again. Because the pegs, if you want to use an inch of steel or an inch of iron, whatever, you go right ahead. A ferrite inch, that's crazy. Even cutting up, a hanger or welding rods, man. I mean, As soon as you get a whole inch, I don't know, maybe it's normal. I think it's a lot. I think it's too much, and you really don't need it. One, this thing is never going to run itself, no matter what I do. No matter what and it's going to look, even if I follow that rabbit hole, it's going to look sometimes like I'm this close to getting it, and it's never going to happen. I'm not going down there. You know, if it happens, I will tell you. I will let you know, okay? But I'm not going to go chasing it because I don't believe in. It has nothing to do with the math or anything about it. I believe you will always need a spark to run anything, whether it be a divine spark or just an electric spark. Without that spark, you got nothing. I don't know why that is. It's like what came first, the chicken or the egg? You know, it's kind of like that right there. And if you think about it too hard, you're just going to miss the point. See, that's awesome how fast that would spin for. That's pretty balanced. Let's see, it's shaking. Now it has stopped shaking. Now it is shaking a little bit. A little bit. It's going to shake a lot. Maybe not. It's epically balanced, but still, I don't think it's balanced enough to go as fast as I would like it to. And I do think in order for it to go that fast, it's going to have to be downsized. One, like maybe even 200%. Or it's either going to have to be downsized or upscaled to industrial. You know, it's got to go one way or the other, but it can't. This one isn't going to cut it. I think it's really good, and I might play with it for a while longer. But the more I play with it, the more I realize, you know, what needs to be improved upon it. And I said, play with it. You know why? Because this is a toy for a grown-ass man or woman. That's what this is. To pretend that that it's anything else, even though it generates electricity, you know, even though it has circuitry and circuit board and cap banks up the wazoo and batteries, and you know, this is a toy. I like it. I like playing with it. I'm sure other people would like to play with it too. Is it going to start? Hell yeah. Now see, when the battery starts wearing itself out, after you play with it for a little while, you get this really happy spin. So there's another spot that needs work when I stop it, and then I let the outer stator start up again. it gets really choppy, and if there's any way to improve upon that. Yeah, I think that not all the time this motor is synced up. There are 6 magnets on the outside and there are 4 magnets on the inside. So every chirp is a 180. There's 6 180s in a rotation. With 2, there would be 12. But yeah, I noticed that. See how that didn't catch? See how I had to counter rotate it? It's either the battery getting low, the duct tape, which may have a little bit of aluminum in it, yoking those magnets. So that's. Oh, the energy that's, creating so much of the light in the crap bank right here is these bad boys. 2,222 turns of 30 gauge. So it's not as thin as the normal 32 that I use. So it's a little bit more current than I normally get, which is awesome. But I've created, 32 gauge coils that'll generate up to 400 volts of AC electricity with minimal current. 32 gauge, that's minimal current. Even though you can go like 42 gauge, and I've got some of that, but you're not going to wrap that by hand. No way. I mean, I think I got like 2 of them done. They broke within 3 days. .42 is really thin. So if anything, I got to patch up the other side so it'll run. There's nothing typical about this motor, so everything you're worried about in a typical motor has no bearing here. It is just a motor, though. No, they don't rotate in the same direction. Well, it does enough work to prevent me from stopping it for at least 12 or 13 seconds. You do the math, bro. That's what I'm going to tell you. That's what I measure torque by, how long it takes me to stop the motor. Not any mathematical equation that I'm not going to be able to get to. And you screw all that shit. You don't care anyway. Just shut up. There is magnetic bearings on both of these, both parts of this motor. No, there's no vacuum chamber that's going to fit on this thing, dude. Or even around this thing. You know how much a vacuum chamber that's this big is going to cost? Any idea? It's like righteous infuriation. Now, the only good idea, really, that I've heard is the shorting of the coil to put a brake on it to slow it down a little bit. Then it will balance out just fine. I mean, the reason that it's shaking from side to side is because there's only one drive on one side of this thing. And there is weight on every side of this thing. And I've been trying to balance that weight out, and I think that I may have found an answer to the weight issue. I'm really close right now for it to being like good, but I think I just need to put weight on the dipoles. Who cares, man? There's no way I'm getting a reading off this thing, especially when it's running. Please use your brains. Use your brains. How am I going to get a reading off of this? Any kind of reading when it's moving? Anybody? I've been trying to figure that out. And I'm not going to weight it down with a fucking commutator. Wireless. That's the only way that I see this happening. If you guys even want any of that stuff, come up with a wireless way for me to get it for you. And I'll do it. Now, there is something that I can do, and I will do. All right, we're gonna get the ends here And I'll give you the DC voltage of the cap bank. $25.8 and dwindling. So I would say it was around 30 with the amount of time it took me to get all that strapped in there. So I mean, that's good usable DC voltage, you know. And then when it's running and it's on, it doesn't light up. And that it means I know that there's something wrong here, because it's not, it is lighting up. You're gonna have to make a guesstimate on all that crap you want to know. You know, like, how much is it producing? I don't know. Can't hook anything up to it. I know the pickup system is producing around 30 volts. That will reach greater and greater numbers the longer it's on. But it will level off at like a certain amount, which I don't know what it is. I would advise putting toggle switches on any ones that you want to try, so that you can prevent the energy from flowing into the battery at any given time. So when you short a coil, what happens? You energize that coil. You send all the energy straight through the coil, and it stays there. The object is to make it stay there for more than the trigger coil intended it to. And that will create a drag on the rotor, and that's what I'm trying to do here. I just don't know how to hook it up through an MPN. I have no idea. So one thing right off the bat, I know I'm going to need to print or buy a new printed base. It's got to be a 15-inch plate or 16.5-inch plate. And it's literally got to print up 7 inches without a mistake. So, I mean, it's a big print, and, you know, You know, I had it priced out. It's going to cost me the better part of $500 to get it printed with carbon fiber, PLA, and I think that's pretty much the only addition I had. I am terribly sorry, but I mean, it's just, there are some very obvious things here that I don't need reiterated for me. And I mean, there may have been a lot more said, but every time I come over there, it's always about just, you know, shit I didn't want to hear. Well, that's what you get. Now, what you guys are referring to as off balance is literally this base is what is way off balance, like it's wobbly. The rotor itself is not off balance. Okay, it's just you guys really, I don't know, man. If you're gonna grouse, do it constructively. And don't overdo it. Yeah. I believe that sound is the disintegration of air around the coil. And yeah, I mean, you see one of these every day, right? You cannot apply everyday rules to something that you do not see every day. And no, you cannot put a bicycle brake on this and have it run the way it's supposed to. You cannot. I've heard that one already, and it seems like it's a good idea. All right, so I'm going to try and flip this upside down so you can see. It's got a maglev on it. And if you can see that. There's one in the hole. There's two down at the base. Okay? Now, if the print was straight, it would be set. But the 15-inch print that I did did not come out straight. That is it's not balance issues. It's the fact that the print isn't straight. It's not like I can fix it simply. You'd have to get a lathe to fix this thing. Okay? You got to understand that the print totally came out wrong. The hole in the center where I put the bearings, one bearing's over here, the other one's over here. You know, the hole did not line up in the center here. Anyway, I don't need to explain any more of it. It's just, you know, I know. So the part with the magnets on it is bent. Awesome. So, yeah, I need to print another one. I need to decide whether I'm going to have 6 magnets in here still. Yeah, and I don't know about it being, putting in less or more. I think 12 volts, and these size batteries are really the optimal for this size machine. I will make a 9-volt rotor though, like a rotor that I will hook up with 9-volt batteries. Because I mean, think about it, pushing 12 volts through this, that's pretty much, that's a powerful combo. And I have another coil that I'm using for my Bedini motor setup. It's virtually the same coil, but it's bigger. This is 777 turns, roughly 2 pounds, a little under 2 pounds. But there's no room for a coil like that. And I have to make 4 of them. Or I could redo the rotor and have it be 2-sided, but I'd still have to make another one. You can't just have one coil on a rotor like this and have it be balanced. So, I mean, the really awesome idea that I had, that somebody gave me, was one about, you know, charging up the drill battery. Maybe if I got like got a small Dremel charger and use a Dremel battery. And then instead of using the cap bank, I mean, I might leave the cap bank on there for aesthetic purposes, but instead of using the cap bank, I hooked at both ends of the pickup coils to either end of the hook it up to that, either end of your plug, and then this would work. It should work. And that would be all 4 pickup coils would be, I don't know, that might be too much of a load. You know what I'm saying? Nah, well, I don't know. All I know is that this is incredibly hard to stop. And this rotor down here is incredibly easy to stop at whatever speed it's going at. And this one's heavier than that one. This one's nice. I like this one. Woo! That was hot. Yeah, I threw 2 of the toroid magnets on here, and the plasma that comes off of this one became polarized and like got white. And then I need to get one of my crystals and put it in here too. The crystal is one pole, and then the bottom of the magnet is the other pole. It's kind of neat. Man, that is fun. Dangerous guy. Thank you, Kale. I appreciate that. Alert the universe to what? No, this right here, I will grab this plasma with my fingers and I will throw it against the wall. That's how undangerous it is. I mean, you don't want to turn it all the way up. It starts zapping you every time it touches you, but I mean, you can touch it literally with your fingers. You can hold this LED in your fingers and it'll turn on. Because it's not high voltage. It's not a high voltage Tesla coil. I mean, it's got to be pumping out something to get arcs, but it's not dangerous. It's really Look at that resistor. You see that? There's a resistor on the magnet. Look at that. Woo! And look at all that iron on there. And this is one of those ones that like dance to the music. You know, if you put some Bluetooth to it, it'll you know, dance to the bass. I haven't tried to see that yet. I know it won't run a circuit, but it might charge a capacitor. I have to get a small enough one to try that. Hey, what's up? How's it going, Mike? Here, see? My magic wand. Yeah, you know what they say about magic wands, huh? What do they say about magic wands? Well, I don't know. There's some really dumb jokes about magic wands. Mike, I got a question for you. Do you know how to make a coil shorting circuit? I'm trying to get a hold of Brandon from over Unity Research Channel because he has the information that I need right now, for sure. And I think it's starting to run smoother because the battery is starting to get lower. I have to charge it up after we're done here. But we'll see. If I get what I need, I might just rebuild it. Oh, you mean I can get a load off the piezo's? Hell yeah, man! I'll hook those up. I might even be able to do that now. It's just I gotta find a right place for them to lay out. I got these new ones. Here, let me get one of these bad boys. See, they're that big now. So yeah, I might have to rebuild it. That'll be sweet if that works, man. That'll be awesome. Hell yeah. And that'll be a completely like almost unique way of doing this. to put piezos in here. The reason is for a load, but I'm back. Holy smoke, my phone died. Hope it doesn't die again. It is plugged in though. All right. We're gonna try something. Don't want to break any of the pickup strand wiring. All right, so what we're going to do we are going to put these two in here like that. Just need to get the a little bit longer jumper wire. All right. Almost ready. I think this, if it works like I think it's going to work, it should work. Because this is going to short out the coil in a manner of speaking. All right, I gotta unscrew something now. My beautiful screwdriver. It should be interesting if I got it right. Just gotta glue back up the stuff that fell apart. I think I'm gonna have to put a dab on them underneath them. Because if those come flying off of here, I might get a deep gash or something. So I'm gonna glue them down. Holy smoke! Well, it did something. Well, that's across the collector and the emitter on the breadboard, which would in turn be the positive and the negative of the coil. But I think it needs to be connected directly to the coil and not the transistor. So that's gonna be a lot longer to take care of. But here, this is what we got right here. Here it is. That isn't normal. See, what I'm going to do is I'm going to go to the coil and I'm going to connect one of these to the coil. So one of these double outputs are going to go to the piezos and one to the rest of the circuit. But in the other clip here is going to be the coil. You see how that's going to work? But I do have a feeling that if I can get this to function as it does over here, that it'll work itself out. Anyway, we're halfway stripped down to putting it back together better. But I've obviously connected this incorrectly. It's now connected across the collector and emitter, which is not the positive and the negative of the coil. I just thought that might work, considering how confined my space is, but I'm going to have to do that double connection because I don't have, there's no clips, like alligator clips in here. There's not enough room. So I got to do it with these clips, and then there's enough room. All right, let me give this a shot. Yeah, I'm gonna need a little bit more time to think about this because now that I look at it, I don't think the way I'm gonna set it up is gonna work with the toggle switch in there. So I gotta figure out in my head how I'm gonna keep the toggle switch hooked up. Yeah, that's it. So this one's gotta be changed. Because that's for the power. Does it go like this? Ah, maybe it goes like this. Yeah, I don't know if I'm gonna be able to do it like this. Let's try doing it the way we have to do it. So, the way I described it. So, screws in this one. And this one goes in this one. positive to positive. Resonance. I think it's working. I think this is it. So that loud squeaky noise was the resonance. Oh, what's going on there? Oh, yeah. Yeah, that's awesome. Hello, hello. So it is a lot slower, a lot louder, but I think this is what right around where we want to be. Awesome, man. That's awesome. Piezoelectric, people. Piezoelectric. I've never been able to let it go like this, man. This is awesome. It's a little off balance, though, now that I've taken all that off. Just a little bit. I've seen it worse than this. So I guess that collector emitter connection would have worked fine. But this way works too, and that's awesome. This is a more direct connection. Awesome. That's awesome. It stopped. That's it, man. That's cool. Thank you, Mike. Awesome. So there's no need to really even glue them down because it's not going that fast. But it's like, it's not even that it's more stable. It's just that it's more controllable. It's slower. Sweet. If that's all I wanted to do, then that's all I wanted to do. Oh. I'm just wondering what happened, what the hell, with the balance and everything, because this is like a gram, a half a gram. I don't know. I'll have to figure that out. So neat. Here, let's see if it's squawking again. And it was. It does that, I guess. But that's working. It's like a drum. It's working great right now. Hello. Yeah, it does. All right, let me see here. I wonder if these will work with one of these on top of it. No, that's not going to work. It's pretty, it's a lot better. It might not be perfect. There's still a few things off. Looks a lot better though, I think. Now this part right here needs to be reprinted, but I'm talking about the center. I wonder what that's doing with the battery's voltage, having it in series across the coil like that. I think it's making it last longer, like drawing it out more. The piezoelectrics, I think that's what having them in series actually does. And doing them in parallel works on the current. Pretty much just like a battery or a capacitor. Hell yeah. Well, I think I've solved my biggest problem. I was getting it into a safe speed because it was like just running away with itself. So this is awesome. Thank you very much. I appreciate everybody pitching in with useful data. And stating the obvious is never useful. So, you know, and pretty much we can consider what the obvious thing is what can be observed here. This is the counter rotating pulse motor, a DC brushless motor. The stator and the rotor both spin. In this case, the electromagnets are on the rotor, and the permanent mags are on the outer stator, which in this case can spin. So, and I guarantee you set it up so the stator can spin, it's going to counter rotate every time using a whatever method of switch. I've used reed switches. I've used Hall. Well, I haven't used Hall effect sensor. I don't know what a Hall effect sensor will do, but I know that a trigger strand and a reed switch will all counter rotate. But I'm pretty sure everything will counter rotate because when you push off, it's an equal and opposite reaction. Yes, indeed, it is, and it'll happen every time. As long if you make it so the stator can spin, it'll happen every time. You don't need to put diodes in. You don't need to do anything special. It will just happen. Now, I guess the ultimate engineering thing is to make it stop. I mean, I guess we're way past it, both of them spinning, and everybody wants me to stop it. And I'm like, why? Why do you want me to stop it? Why do you want readings from this? Why do you want to know the joules? Why do you want to know all this stuff? When you don't care. Why do you want to know if you don't care? I'm just curious, because we all know the answer. And it's a counter-rotating DC brushless motor, sir. Using piezoelectric as a braking system. That's what the bell sound is. The clicking bell sound. And currently, I don't know if this is really producing any of the electricity that it used to. Oh yeah, there's the light. It's just that it's way brighter when it's going faster. That makes sense though, right? Because it's a good portion of it is AC from the magnets. Because I got 4 of these coils on there. That's 2,222 turns of 30 gauge. It's 5 ounces of a coil. Got 4 of these on there in series, connected to the cap bank. Again, I have 4 of these, and they go together like this. So this is a set. You got your drive coil with your 20 gauge and your 28 gauge, and you got your 30 gauge in proximity. So when this one hits, this one's going to get a shock, and it's going to get juice. The imprint from this one is going to be, and it's perfect. The size of these coils are 5 ounces, 5 ounces. You're either going to scale up or you're going to scale down, but this is it right here. When your drive coil and your pickup coil are the same dimensions and the same size, when this one hits, maximum saturation is going to occur. Maximum pickup is going to occur. There's no reason to do it any other way. And if your parameters don't allow you to fit 2 coils on the thing, you got to change your parameters to something that makes sense. And you know, I got blessed because these bobbins, I bought them at the store. This whole thing, and somebody might consider it to be not a blessing, but this whole thing is based around this bobbin and its size. Because it's the only thing that I didn't have control over the size and shape of it. And in my opinion, it's a perfect size and a perfect shape, especially for most of the magnets that I use. So there's just no negative, because those are the things that I care about. So there's no negative. And I'll show you what I mean. Even these ferrite discs are a perfect size for the magnet. And even though they don't line up perfectly, that is going to be a super duper charge right there, or push, or whatever. That's epic. Epic. Inch hole, inch hole. You know, epic. And then the big Neos that I'm using in there right now. Right here, these ones. Because they're Neos. But look at that. The edge of the Neo, which is where the most powerful energy is right on the corona of the coil. And that is, again, epic. Doesn't even have to be a round one. It can be this square one, and it's going to be epic. It's not going to be as epic as a round one, but it's going to be epic. And there's no way you can change that fact. Yeah, it should be a round one. Round one would work best with the round coils. Look at that, man. That is brilliant. That's going to have to stop soon. I think that battery's almost dead. That's awesome. That's exactly what I've been wanting this whole time, is to be able to walk away from it. No, I can't speed up and slow down currently. You need to do that wirelessly. Why would I do that, dude? And I'm pretty sure it is easy once you get into the flow, but we're heading away from internal combustion engines. Maybe it could be for fun if I had a garage. But as you can see, this is an indoor setup, and building an internal combustion engine isn't going to happen in here. I gotta keep on, and there's probably 100 more things that I'd like to say, but I'm not going to do it. It's coming to a stop. I'm going to just let it roll out here. Wow, it feels so good to let that happen. Why do you care, Rick? Let's start there. Asking what it is one thing, but asking what it does is something totally different. You got to pay for that one. Heck yeah, man. I mean, I just put some piezoelectrics on it, and I think that when I juice up the battery, it's going to be epic, man. It's going to go for a while because I've used it now for like 5 days without charging the battery. So, but those piezoelectrics are slowing it down, so it's like usable. Yeah, good deal, kid. I hope you can make use of it beyond what I can do. Because I know that all this plastic amounts to what is considered to be a toy. So when people are like freaking out about all the typical nonsense, see, he wants to stop now. That's awesome. Let it run all the way till it dies. That's cool. I think I'm gonna have to do something better than duct tape. There's not barely any room there in between the wall and the edge of the coil. So I don't know what else I can use. Maybe Teflon. Maybe like a couple wraps of Teflon around there. Because I know that the electrical tape stretches out way too quickly. The coils just put way too much pressure on it, and the coils start coming off, which is not a good thing in this confined space. So the duct tape is working well, but I think it has an aluminum yoke effect because the response to the magnets is different from the coils with the tape on than with the tape off. So that's proof. You know what I mean? That's proof that that is occurring. And what I mean by that is so much going on right now. Lost track of that one. So what I do to charge these up is I just plug in my T-Energy battery charger and charge them up. So I need to put all right, so you got your typical DC brushless motor, right? With your coils out here, and they're like glued down, and then the magnet passes by it really fast and you get some energy and it moves, right? Same principle here, except you got your coils on the middle, in the middle, and both parts of your motor move. Simple. That's everything gets magleved on the pole. Okay, everything gets maglev. There's a maglev down here, which maglevs the magnets. There's a maglev inside this dish, which maglevs the rotor. Everything's floating. This will go on for a long time. So, I mean, with the amount of force that I feel when I try and stop this thing, I feel like I could put on some pretty heavy blades and this thing could take off. And not any like wimpy little flaps of plastic. That's not what I'm talking about. I'm talking about like some blades, maybe even wooden blades. I think I'm going to print off some propeller blades and attach them to this somehow. But, you know, I got to get the stopping mechanism first. I mean, that would come after I know how to stop it without touching it. There's got to be an on-off way to toggle the toggle switch using an infrared relay and a TV remote. No, let's say it doesn't generate any current or electricity. All it does is move, because we're never going to get that reading. That reading's never going to occur unless you put the meter on the rotor and have it balance out. Will you ever get a reading off of this thing? I got a reading off the cap bank. I had to stop it, hook up the meter. It's not, no. This is what it does right now. But I was just getting to the point where I was saying, since it's a rotator, I might be able to get some sort of lift off of it by changing its design a little bit. But it's like dying on me. So, like my phone did earlier. It's my love of electronics that birthed this thing, man. There's no other purpose for it. It is my... You really got to come across a different way. I mean, do you care? Or you just can't figure it out? Ultimately, when it's all balanced and it's perfect, this system should be able to spin faster than, you should be able to should be able to see right through it. Translucency is what I'm talking about. But I don't know if that build will have piezos on it or not. All these are for the same purpose, to satisfy my curiosity. Now, those people that know a little bit about what's going on here, it's a DC brushless motor that counter rotates. Really easy to make a motor counter rotate. It's incredibly easy. You used to have a base that spins, and you put your magnets in it, and they'll spin on their own. Okay? You don't need to attach anything to it. The coils in the middle, see, that's the other unique part. The coils are in the middle now. Right? And it's like, God damn anybody who thinks it needs to be more than that. I love this stuff. That's why it's here. That's why it's spinning. And whoever thinks it needs to be more than my love for the craft, go, just bite me. All right? Bite me. It's microbiome, man. I'm serious. That's all this has to do, because that's what I said it has to do. Does it need to do anything more? No. Does it do a bunch of stuff? Hell yeah, it does. It's a DC brushless motor. But you don't need to know any of that information, and neither do I. Because I'm going to tell you right now, you're not going to hook a meter up to this thing. I'm not going to do it. Tell me how that would work without adding anything to it other than a meter. It just stop right there. And it's like, it's just some of the suggestions blow my freaking mind. I mean, I had one suggestion for a vacuum container that would literally cost me like $5,000. Retarded. I'm not a philanthropist, man. I don't have millions in the bank that I can just frickin' throw around at stuff. Keep your suggestions within the parameters. And right now the parameters are, everything has to fit on this rotor. Okay, you want to see how big that is? And sure, if you're going to buy me a vacuum sealed container that is this big, so I can put the whole thing in there, because the whole thing needs to go in there. I mean, and I don't know, man. I don't know if I have a right to be mad or what, but it ticks me off, because it's like, It's not even a good suggestion if it can never happen. Not even a good one. And you want to know one person who knew that? Tesla. He knew that. That's why he blew all of his money on the frickin' tower, because he knew that. And I don't know a more miserable way to die than the way he died. I mean, he was in his favorite hotel room, but he was being ass raped and stolen from as he was dying. Can't think of a more worse way to go. I would be bitter in my next life, I guarantee it. Yeah, I have no idea what that means. So I'm just running out the last little bit of the battery before I shut it down and juice it up again. Disrespectful asshole. You know, you don't have anything nice to say. Please leave. Don't make me boot you. Just leave. It's basically shorting out the coil through the piezos. You're connecting the positive and the negative end of the piezo through two series piezos, which and consequentially shorts the coil out. So that's what's happening through the piezos. You need a minimum amount of voltage in order for this system to work, obviously. Mm. So cool. And we got it slowed down, so I'm going to juice it up, and the next time we're going to see if it works, like really good. Thank you, sir. Wow, what a douchebag. Yeah, thanks. Now, seriously, man, I'm talking like you don't want to mess with me right now, because you will never see me again. What a dumbass, stupid fucking retard. And share your opinion with me, man. I'll share mine with you. Straight, man. Right out of the freaking box. Hello. Yeah, it's a DC brushless motor that's kind of inverted. It has the coils in the center on the rotor, and it has the magnets on the outer stator, which can move, of course. And that's basically all it is. It's a DC brushless motor running on two piezoelectrics. Um, it's got 6 mags and 4 electrodes, 4 electromagnets. So every time there's a 180, there's 3 180s on the outer and 2 180s in the middle. I don't know how to explain how it works, but if you do it in your head, you can kind of see it. But for the motor that's on right now, um, you're getting 6 hits per rotation. And then if you had the 180 circuit, you'd get 12 hits per rotation, but you've only got the one, so it's 6. It's really simple. I might hook up 4 drive coils in the next build with four batteries, each with their own piezos, which is going to be really difficult. I might have to actually get the smaller ones. These ones right here. And use these instead of the big ones. That would be sweet, I think. And then just turn it on and yeah, anybody looking for controversial stuff, we got the wrong place here. I'm not down for any of that. Like, is it a time machine? Some people think that if this gets going fast enough, it'll create a time divergence. Yes, because some people think this could warp time somehow. Hello. Man, I'm sorry, dude. Um, yeah, we don't talk about that kind of crap here. You got like 3 seconds to say you're sorry. Yeah, that took about 10 seconds, which means you didn't take me seriously. I'm really just sick. I guess it's humanity that's pissing me off right now. It's not a weapon. It's not a bomb. Maybe some jackass made a bomb to look like this. Fuck him. Okay? Hey, Ty, what's up? Yeah, I'm just, I don't know, I'm kind of popping off at the mouth right now. People bringing, talk about weapons, and it's a shame. It's a damn shame because, I don't know, man, it's like, I don't have a problem with people from other countries at all. You know, and I encourage the building and sharing of ideas, but I mean, the whole, you know, you walk in and I'm already on eggshells, man, and you're talking about straight jackets and weapons, and you're lucky I only gave you 10 minutes in timeout. You know what I'm saying? It's like, it's a peaceful place until, you know, you start, you know, having a sense of humor that rubs me the wrong way. Until you start offering me your help when I don't ask for it. All that is insulting. You got to realize that. And that means you just, and it's fine. I guess it's okay, but I'm just calling you out. And I'm happy for many reasons too. You know, I'm happy that this thing makes people think a little bit. You know, the people that actually wonder how it works and why it's working and all this other stuff, those people are awesome. Okay, the know-it-alls, you know what how I feel about you, man. I've written several posts about people who know everything. Yeah, just I don't know you, and you don't know me, so you don't know everything. And I'm gonna look back at this in a couple days, and I'm gonna be like, "Yeah, fuck you, jackass. You are a jackass." Yeah, I was thinking about that. Writing and like making a 3D print that could like hold these in. And I was just, you know, I'm examining how much space I actually have to make that happen. I have to be a pretty precise print without being able to get precise measurements. You get close, but as for precise measurements, this isn't. Maybe I have them on the Tinkercad. Yeah, I can get them off of Tinkercad. Get the exact measurements off of there. But then I think there's like a total of 1/8 of an inch that they stick out past the rotor. So, you know, yeah, I could definitely do that and look a lot nicer. And then maybe make it like a, and then make an outer one. I already have the outer one done. Just need some plexiglass on the top. Here, let me put it together for you real quick. So this is the outer part. I gotta work on the inner part still, but see, it's like, if your freedom is gonna make my life more difficult, yeah, I'm gonna pee on your freedom. Anything that's gonna make my life more difficult at this point gets negative marks from me. So if your freedom of speech somehow makes me feel uncomfortable in any kind of way, you're gone. And I've been doing it all night. I mean, just the jackass's name, Crybaby Killer. What kind of fucking retard fucking has a name like that? What a jackass. And that'd be awesome. Put some plexiglass up here, or have the inner rotor come up like this from the inside. That'd be sweet. That'd be cool. Because if you look at the actual angles of these two, that's an actual Utron anglage. So if you just kept this going all the way up to the top, which it won't do because of the rotor, it would be an Utron. So this rotor won't fit in an Utron. But if you make this little diamond part, you know, this little straight up part, now it fits. And it doesn't look that bad. I mean, it actually looks maybe even better than a Neutron. But a Neutron was never about the looks. It was about how fast it can go. And the meaning of its shape, which is the shape of the universe as it expands. At least that's what our previous knowledge was. But I think that the James Webb Telescope is going to open up more and more and more every day. It's either going to exemplify that as a fact, that an Utron is the shape of the universe expanding, or it's going to debunk it. But the James Webb Telescope is going to tell us everything we want to know currently about the universe. Physically, what it looks like, where things are. And yeah, it matters a lot. Hello. It's not a toroid, really. It's just an encasement. It's just encasing it in plastic. It's just, there's no practical use for it, dude. And I guarantee, man, like anytime, why would you ask me to explain this? All right, you know, just, I think it looks dope, man. So cram it up your butt. Yeah, whether or not I'm sad and depressed is none of your frickin' business. Thank you, sir. I really appreciate it. I've been in. We're working with DC brushless motors. I don't get over to the phone as often as I should, but tonight coming over there has been a really mixed experience for me. So I might just stop doing that. And you guys can just kind of figure it out for yourselves, I guess. Oh, I think that's my bro. Yo. How's it going, Captain?
Good. All right. How you doing?
I'm doing a live stream, and I've been ranting like all night.
Nice. There you go.
Oh, thanks.
Thank you, man. I really can't be doing this without you, but I'm gonna switch it to like something closer where I don't have to drive. So hope you're putting all the miles on the car.
Sounds good.
Oh man. All right. So yeah, no, like I just got to be stronger than it. I'm calling it now. So that I'll just leave it at that. Right.
Yeah.
And then we got to do like I don't even know. Maybe a card game.
All right. What time is it?
8.
8 o'clock. Society, man, how's it going? Oh, nice. No, is it freaking you out?
Oh, it's nice.
Oh, it is nice. Nicer. Isn't that good?
Yeah.
And the battery's like pretty dead.
Mm-hmm.
So I'm thinking it'll curtail the speed at least enough when it's fully juiced up. And it's awesome. I get to walk away from it now before I have to like watch it like a baby. And that's great. When people disagree with me openly, I just put them in timeout for 10 minutes.
Right. It's easy.
Yeah, it's easy. That's right. And then the people that are real douchebags, I put them in, I hide them.
Yeah. That's good. That's
I try to give everybody the benefit of the doubt.
exactly. Everybody gets a shot.
Everybody gets the same 2 coins. You guys are the best.
You've been at this for a minute.
Yeah, my phone died.
Okay.
I came back to life.
And they're back.
Yeah.
Yeah. They'd be like, what is that? That is cool.
It's like the crybaby killer said that, you know, I was like crying and I was sad and depressed. Gone.
Right. Yeah. Easy pickings.
Yeah, $4.99 per turn. This thing spins a lot. Mm. So I think, here, let me get it. Maybe I don't even have to take it off of the wheel there. All right, we are gold. We just need this one. And where's, there it is. This one. Now we got our red light on, and that's probably going to take a while. So thank you all for hanging out. Really appreciate you stopping by, taking a gander or whatever this is. It's 88 miles per hour. Stop shouting at me. All right, well, peace out.